Hello everyone, my name is Sean, and today we're going to be doing Leetcode. I haven't posted in a while, and I'm really sorry for that. I've been doing Leetcode and trying to keep up with school. Um, I've been doing Leetcode consistently, and then I questioned myself, why haven't you posted a video of you just doing Leetcode? Because might as well make a video. So I will just be doing Leetcode for a bit, just record myself doing some problems. I have been doing it consistently for like 8 days now, as well as school's been going really well. Like right now, we're learning about the kernel scheduler, really interesting, or the operating system scheduler. But the kernel is also responsible for scheduling, so yeah, that's fine. Yeah, this kernel scheduler, it's been going good so far. My concurrency course has been going really good. I've also been trying to use a lot of C++, but I'm starting to still go back to Go because I want to build some stuff and get better with system design. I feel like my system design is definitely something I need to work on, but I have been doing this problems, skipping all the hards because all of them have been cooking me. Slowly been doing the easies. I think I only did the 2-pointer rain trapping rainwater. And the intuition for that one was even the prefix suffix. So I'll definitely be doing more than just reverse linked list because if I'm being completely honest, most easies wouldn't take me more than 3 minutes to solve. But yeah, let's just do a few and just see how it goes. So right now I'm on the linked list section. So I have done sliding window, stack, binary search, 2 pointers, arrays, and hashing. Okay, so let's see. So you're given the head of a single linked list, reverse the list, and return the reverse. Okay, so I think this is a very classic. So essentially, we want to make this point backwards and return this as the head. But if we make this go backwards, then we lose the reference to this node. So instead, we store the next of this in a temporary variable and make this point somewhere else. And we can repeat this process. So this will the this dot next the this dot next of this will be wait, how do we do this actually? So I can create a temp variable to equal to this node, to the head.next. And so me doing this, I haven't done this problem. The last time I did it was last year. So it's been a long time, but I still know the overall intuition, right? So we want to make this node point backwards, and we want to make sure we store the reference to this node, because with this node we can get this node, and with this node we can get this node, and with this node we can get this node. So the idea is we store a temporary variable to be the head.next, and we make the head point somewhere. Well, we need a way to make this point backwards. So initially the previous will be null, and then you set the next of this to be previous, and then we move the previous here and we move our current forward. The same process begins as well. So we store the temp will be the head.next, so the temp here would actually be 3, and then we make this. Now we've cached this reference. We don't have to worry about updating this node's pointer to the previous, so we make this node's pointer point to backwards, not backwards, to prev. And then the same thing, we're kind of juggling around. We make our current pointer go to this pointer or to the temp, and the prev comes here, and I think we do the same thing over and over again. Eventually the prev will be at this node and the current node will be out of bounds. So we're going to create a current pointer to equal to head, and we're going to say while current. So what are we doing? So each time we're creating a temp variable, it's just going to equal to the current.next. We're going to create a prev actually, because we do need a prev here. We're going to make, since we've stored the current reference, we're going to say the current.next equal to the prev, and then we're going to have to update the current to equal to temp. So that's now going to go to the next, which would be temp, and we want our prev to actually equal to our current before we actually update here. So we want the prev to equal to the current and the current equal to the temp, and then we want to return the prev because that will be the last node and representing the new head. And I think so that's the first problem. yeah, so yeah, okay. So that's the overall solution. Not really too much to say about that one. So let's go to the next question. Merge two. I'm really excited to see the mediums actually. So I'll try and speed up and I'll tell you my thought process. Last time I solved this question was August. Ooh, why did I solve this problem? But anyways, merge two sorted arrays. So two sorted lists. Okay. So we're given two heads, and we want to return a new list that has this 2 1s, 2 3 4 4. Okay, so yeah, so my thought process is that I would have one pointer here, one pointer here. If this node is greater than this node, then we append this node and make it go here. Well, in this case, if it's greater than or equal, we still move this pointer to move here. This pointer will remain here. Here it's actually greater than, sorry, it should be, if it's less than or equal to this, we store this in the head, update this to point here, and then this node will still remain here. At this point, this is actually greater than this, so we add this one to the thing, and then we remove this reference here. And then now this is bigger than this, so we add this 2. The 3 will still here, 2 will still be here, 4 is bigger than the 3, so we make the 3 come here, and so on. There is cases where, obviously, I do know it's possible for the list 1 to be not the same length as the list 2, so in that case we would still have an additional loop. Here it's literally telling us that the edge cases, so let's quickly just handle that because not list 2, return none. So if okay, now we can store some two references. So we'll call R1 is equal to list. I can be asked with the actual. Yeah, so now we have these two pointers which are pointing to the heads, and we want to say, wow, these are not null, right? Because we want to keep on updating. So if R1, we also need a res actually. We actually build our result. We will be returning return res.next. We do need a dummy pointer so we don't lose a reference of. So we will make cur equal to res because we don't want res to go to res.next, else we're going to lose our references here. So if this the same thing, so if yeah, I think we don't have to yeah, we can and then we can just do this outside, so we don't have to do it in both of them. And then we're not done because yeah, kind of want to and we're basically doing the same thing for R2. Yep, I think that should be correct, unless I am using, that's a list node. Ooh. Okay. Okay, so let's see. Did I just cause an infinite loop? Ah. That's embarrassing. Yep, there we go. Okay, so little mistakes there and there, but yep. Um, but yeah, I think most of you guys would know the intuition to how to solve this. But yeah, what I did wasn't really impressive. Let's still keep on going because I'm actually curious to see. Oh, okay. When was the last time I solved this? 2024. Damn. Okay, but I still understand the intuition, right? So the intuition is we are using a fast and slow pointer. And the idea is if we have a fast pointer that's moving 2 times the speed of the slow pointer, at any point, if the slow pointer and the fast pointer are the same, then we know there's a cycle. Because if I have at this, they both, if the fast pointer starts here and the slow pointer starts here, the fast pointer will come here and the slow pointer will come here, and then there's a cycle. Because the fast pointer is always going to go to the dot next. So that'll be here, and the slow pointer is always just going to be going once. And at some point, if there's a cycle, they'll like grind up in the same node. So the same thing here. Yeah, because there is a cycle. So in this case, the slow pointer will be at 1, the fast pointer will be at head.next, which is the same thing. And at some point they will. Okay. Yeah, so if there isn't a head or there isn't a head.next, then there can be a cycle, right? We have to initially as a slow pointer and a fast pointer. I guess. If this is impossible and they never met, then we can say then there was no cycle. Yeah, I think this is correct too. I mean, the intuition is because if any of them do, ooh, what did I do wrong? Okay, so okay. If there is an SL.next, then we are going to do this. If there's an FS, I guess. Yeah, because if there's an end, then there's no cycle. Oh, it's again the same thing. Oh, because fs.next could be none, and I'm trying to check. Okay, so I need to check. Oh. Okay. Okay. It's kind of a... Guys, this is going to be... Oh my god. Um. Oh. 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 That's not good. This isn't. I mean. Yeah, it's just edge cases, like with the node references. Yeah, I mean, this is a very edgy way to do this. Um. Do I care? No. Okay, let's go on to the next, because I want to go into the mediums. I haven't done this question before, I don't think. Reorder list. Okay, this should be interesting. I haven't done this ever before. Okay, so you can literally see there's nothing there. Okay. Okay. Okay, so it's like this, then this, then this, then this. Okay. Okay. So we're trying to reorder the list such that it's kind of the so we are modifying it in place. So they do want us to use the same head pointer. Okay. Okay, so we want this node and then this node and then this node and then this node. Right, so So it's kind of a scuffy way of doing it. So if I think about it like this, these nodes okay, so it's gonna be L0, Ln minus n, Ln, L1 because this moved forward. Yeah, so essentially so what happened? We could okay. 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 Okay, so this node came here. This node went forward. This node will come here. Oh, right. Okay. Let me lock in. Okay, so 5 becomes the okay. So it becomes L0, Ln, L1, Ln minus 1, L2, Ln minus 2, and so on and so forth. Okay, so L0, Ln, so it'll be 1 and 5, and then it will be 2 and 4, and then 3. Okay, so this and this, this and this, and then this. Okay. It's kind of like something like this. Right. Yep, that should be a 3. I should probably time myself as well. Oops, so sorry guys, I forgot to time myself. Yeah, because it's a singular. So this will I will need a pointer. Do I need a pointer at the end here? Do I? I need a way to move this to the end. What happens if I move this 2 forward? I move this 3 forward. I move this no, because it should be the value of the list nodes, only the nodes themselves. Oh, you may not modify the values of the list nodes, only the nodes themselves. Okay. Okay. So the dot next of this has to be 4. And the problem is that you can't go back, right? With a single linked list, I can't just go backwards. So I can't think of this as a list where I can swap. There's no indexes here. There's only forward, and I have to find a way to kind of make this come ahead of me. You have to modify the head in place. Okay, so the question is, how do I move 4 from n to n minus 1? Oh, no, sorry. Yeah, so n goes to... Okay, so that's there's kind of like pre-made slots they should be in. So we're basically saying the last element should be on the second element. The second to the last should be on the fourth. Right, so if this is 4, right? If they all have indexes like 1, 2, 3, and 4. Let's look at this example. So if we have like this, then where should this one be? Zero should just be 1, right? Because that's 0. But 4 has to be on the length minus 1. Oh, no. And we can't just modify the values as well. We have to actually modify the references. Okay, so 2 is always going to be, so 2 here is in front of here. So we need a way to store this. We can't lose this reference. So we need a temp to store 2. Okay. The question is now, when I do store this temp, I have lost my reference to 1. So how do I make 4 go here? Kind of a tricky pickle. But there is a solution. I will figure it out. So we have 1, 2, 3, 4. If I have a book, can I have a book? Just write something down. Just get a book. I think having a paper will be really useful here because allow me to actually visualize what I'm doing here. So I have 1 as a node pointing to 2 as a node pointing to 3 as a node pointing to 4 as a node. And I want the results to be 1 pointing to 4 pointing to 2 pointing to 3. Is there some kind of property that's still holding here? 4 is ahead of 3 now. Wait, 3. Hmm. Yeah, because I see why they said you shouldn't be able to modify the array. That's because if we have the length of the array, which is 4, the general formula would be kind of like the current. You have like an accounts, which starts at 0. So this would be 0. But they said you may not modify the values of the list nodes. Only nodes may change. Okay, so I don't want to cheat. I need to think of a way to actually, no cheating here. Okay. Question is, how can we make 4 come all the way back? And you have to modify the list himself. Wait, I just realized something. Because I'm modifying the list itself, doesn't necessarily mean I can't use any extra space. They didn't necessarily tell me not to use any extra space. Okay. Because what happens when I reverse this? When I reverse it, it becomes what? 4, 3, 2, 1. And it becomes 1 to 4, 2 to 3. And that's it. Alright? Because then it just becomes this. I only need to iterate to the end, to half of it. And then if it becomes, but I don't know if I'm allowed to do that. And then it'll become 5, 4, 3, 2, 1. So the length here is 5. We'll only iterate to 5 divided by 2. Floor division should be 2. So we'll only have 1 to 2. Sorry, 1 to 5. 2 to 4. Yeah, so we'll have to actually, if it's an odd length, we have to go +1. Should just give us 3. These are things that can be checked. But I don't think I'm allowed to do that. Or am I allowed to do that? If I have this in reverse order, a copy, can that help me? Because the next will be this. So this would be my head. The current on next will equal to the equal to this current, and then I update. But then I need a temp variable, which would be my temp variable here, and I actually go to the temp, which would be 2, and then the same process again. It will be 2 mapping to 4, right? Right? And then I have my temp again. My current goes to my temp, and then 3. My temp will be here, right? Yeah, it'll be at 3, and then 3 will map to 3. Yeah. That's the first thing that comes to my mind. I could create a copy of the list, reverse it, like. And what I mean by a copy of the list, I'll be over and squared because I'll have to go to the end. I can't really go backwards. I would need to create a copy of the entire list, reverse it, which is linear work if I just create a copy and then reverse it, and then kind of use this hack, right, where I'll store temps and adjust the thingies. For now, that's what I'm gonna do. I don't think I'm allowed to do that. Probably is a better way, but just to have some way of doing it. That's one thing that's come to my mind, because I could create a copy of the list, reverse that copy, and then kind of have the current node I'm on. So I would have like a current node, which would be, it has to be in place, so it would be the head. I do have a temp. The temp will be the current.next, which is going to store this too. And then this head, I'm modifying the head here, so I'll be current.next is going to equal to the currents, the copies current would be 5, and then I go to the temp, which would be 2 here. So I haven't lost reference to the 1 here, because but the question is, how do I, because I would have 1 to 5, so the head will be 1 to 5, but then how do I update that? Yeah, so I could have a current, another kind of dummy pointer, which will be pointing at this node. Yeah, makes sense. And then we just do the same thing over and over again. But we also do need to know the max. We need to know the length, because if it's an odd amount of elements, then we need to go to +1 and then exclude the last next. But if it's an even, we can just go exactly half, and then we have 1, 2, 4. We have 1, 4, 2, 3, which is the correct answer here. So, I mean, let me know. You guys, let me know in the comments what you guys think. Let me know if you think that was a cheat. This is what I'm gonna do now, because I don't want to spend more than 20 minutes on this. What's the next question after this, by the way? It's remove the nth node. Okay. Anyways, it's fine. So I will create a copy. Create some kind of copy. I will reverse that copy and update head accordingly. Let's just say accordingly. Yeah, something like that. So the question is, how do we create a copy? So we're going to create a function, create copy. Just going to take in a head, right? It's going to have a copy, which is going to go to node. Oh, so it's going to be a list node here, actually. So we have to be quick, and then we'll just say while create cur, just going to go to head, because we don't want to update the reference here. So while cur copy yeah, it's fine. I'll do that next. Oh, because if we do that, we also lose. So we also need a. Bro, so much stuff. Okay, we don't want to lose any references here, so we will be returning the copy.next, as the new yeah. So right of the current vowel, we want to update the dummy to equal to the dummy.next, and the current equal to the current.next. Right? Because we create this, da 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 next. Yep, that seems correct to me. So we create a copy, we reverse the, so we're going to create a function, reverse list. So it takes in the head. And the thing about it is literally what we did last time, right? So create prev, none. It's a combination of like a bunch of stuff. Yeah, so head, current, gonna equal to head. Man, how have I forgotten? Yeah, it's possible for none. Number of nodes is between 1. Okay, so it's at least 1. Yeah, so we can just have an edge case for that. So we will create a copy, so we'll call it copy. Obviously, assuming I didn't implement that incorrectly. Yeah, so it's 4, correct. So now we essentially want to update the current. So we're going to say dummy is going to equal to head. Right, and now we want to kind of like map them. While I was creating the copy, I can return 2 things actually. I might as well have a current n, and this n will be, yeah, should be n plus equal 1. We're going to return an n, so I will be destructuring both. I will destructure both the copy and the next, an n. And now if I print out n, it should give me the length of the list. Oh, almost 20 minutes. Oof. Yep, which is 4, and that one should be 5. Okay, cool. So yeah, so what are we doing? What are we doing? Yeah. Yeah, so we need a way to create the dummy, which is equal to head. Yeah, so what we're trying to do here, we're trying to say, okay, so we want this and this. How do we do that? We do dummy is equal to head. Yeah, so we want the head, dummy. So yeah, so right, right, so we want head. I'm gonna move this down so I can actually visualize what I'm trying to do. Update accordingly. We do not have that much time. Yep. So yeah, so head. Oh, so we don't want to do that. We actually want a dummy. Yeah, so we do need a temp to equal to the dummy, right? Because we can lose this reference, and then sorry, I just phased out for a second. Yeah, so it's re234. Yep, so now we're now here. Oh yeah, so that's the extra pointer we needed. Oof. Temp. Gonna dummy x. Dummy x dot next. Dummy dummy dot next. Yeah, because when we put this, we needed something in the points of this. Yeah, so okay. Yeah, I'm being kind of intelligent here. Yeah, none. Oh, but I have to be consistent here. So yeah, let's do that. So dummy, it's gonna be that. 1.next brain. Come on, hello. What time is it? It's like 10 a.m. It's like 10 p.m. It's not even that late. 1.next will be the list node of dummy c dot next, which would be this, which is 4. I mean 1. We want to go to 4. Think. Yeah. But then when we do that, we're saying 1 next is going to be 4. We store this in a reference. We say dummy.next is going to equal to a new node, which is going to be 4. We move to 4. Yeah, so this should be head dummy underscore x. This was the x thingy. So we move to this 4 with dummy. and then so now we're this too. With dummy x. Oh my god. And this 4.next. Where's dummy c.val coming from? Oh, because yeah. Right. So we're at the 4. So now, wait, okay, let's simulate this. Let's delete all these other examples and see what we get from here. So we'd only iterate to 2. So we're gonna say in the first example, temp is gonna equal to dummy x.next. Dummy x.next is gonna be what? It's gonna be this. Is gonna be 2 dummy.next, which is this, is gonna be pointing to 4. Dummy is going to then go to 4. Dummy x is then going to go to 2. Dummy c is then going to go to 3. We go to the next iteration. Dummy temp is going to be dummy, so it's going to be 3. Dummy dot next is going to be, it's going to go to what? This is going to give me 2. It's going to give me 3, sorry, which is incorrect. I needed to so it does this now. And then 3. I'm not done yet. I'm just trying to. Which is 4, goes to 4, goes to 3. We put the next of this is going to be an x.val, which would be 2. We put 3. It's going to go to 3. It's going to go to, yeah. But then it's going to be incorrect because, oh, it still puts 4 before. Oh, bro. Oh, because yeah, make it continue. No. Okay, so yeah, so this is the last case. We just have to make sure it doesn't. You just have to make sure it's not bigger than n, right? So we'll do one more scan. Bro, the dummies is becoming crazy. Alright, yes, because it has to be one indexed. Wait a second, what? I feel like I'm doing something extremely stupid. It's only logging once. Oh, I see. I guess we are successfully updating the thingy, but it should actually be equal to head. That's the last thing we need to do. because we are updating the head first. I think this is what I meant to do. But then the question is, why? Right, no. Oh my god. Bro. One. Oh, wait, the expected is... Oh. Oh. Yeah, okay, okay. Okay. Oh, okay. Oh my god, that was literally... yeah. Oh my god, this is taking so long. I still might even still be incorrect. Yeah. Hey, mom. Okay. Let's see if this passes. it doesn't pass, then I'm trash. Okay, so I did the most unoptimal solution, and yeah, do I even keep on going? Wait, let's analyze time complexity. So, it is order of n time because we're visiting each node at least once, right? So it doesn't go out of n, right? This condition I'm doing at the end, where I'm actually appending, it's actually going up to half of n, right? We'll never actually pass n, right? So the biggest factor here is, I would say complexity is over n. What's the acceptance rate? 68. I feel like I overcomplicated this. Space complexity is over n. Okay, before I end the video, I'm actually going to check out some submissions and solutions. See what people are doing. How many lines of code was it even? Was slow and fast? Okay, I am feeling kind of hungry. I will watch the solution, and then I will make another YouTube video, like telling you what I learned from the solution. I definitely think I overcomplicated things. I sucked. I did really bad, but yeah, there definitely is a lot of optimizations, a lot of things I could have done better. But yeah, let me know if you guys like this type of videos. I will try and be making more Leetcode videos and just like letting you guys know like what my thought process is, and I'm trying to improve. And yeah, let's keep on going, guys. And yeah, I hope you guys have a great evening. It's 11 o'clock. I'm probably gonna go start writing some Go. I haven't done DSA in a while, but yeah, thank you so much for watching, guys, and hope you have a good day. See ya.